All right. Happy Tuesday. Obviously, I'm not in class today, but I would like you to still learn about index notation and index laws. So let's start off. There's 5 laws. Start on a fresh page, write index laws across the top. And underneath, I want you to start. Just remind yourself, we've done this before, um, that 5 to the power of 4 is the same as saying 5 times 5 times 5 times 5. This is its index form. This is its expanded form. That's just a quick one. We've done that before. So let's start after that with index law 1. Make a new heading. And index law 1 states a to the power of m times a to the power of n. When that happens, you just add their powers together. So here it's just a to the power of m plus n. Now, if these letters are confusing you, they just represent any number. So down here is probably a better example. X to the power of 4 times x to the power of 3 is going to be x to the power of 4 plus 3, which is the same as saying x to the power of 7. That's law 1. Pretty straightforward. Let's go to law 2. Again, if you're in my class last term, we've kind of done this before. We just haven't put it against this index law. And that states a to the power of m divided by a to the power of n is equal to a, and you take the first power away from the second power. So when dividing the denominator's indices are subtracted from the numerator's indices. Now down here, I'm not sure what's happened with my 9 there, but that would be the same as saying x to the power of 9 over x to the power of 3 would be the same as saying x to the power of 9 take 3, which is equal to x to the power of 6. So, about over here, when you're dividing a to the power of m divided by a to the power of n, you just take the numerator's power away from the denominators. Sorry, you take the denominator's power away from the numerators. The last term, when we were cancelling fractions, if we had, well, this would have originally been written as x to the power of 6 divided by x to the power of 2, and we've rewritten it like this: 1, 2, 3, 4, 5, 6, and 1, 2. Remember how we just, if there was an x on the top and an x on the bottom, we cancel it. X on the top, x on the bottom, we cancel it. Now we're left with 1, 2, 3, 4 x's on the top and none on the bottom. But remember, these aren't zeros, they're ones. So it is x, that would end up equaling x to the power of 4 over 1, which is the same as saying x to the power of 4. And if we use that law, that would 6 take 2 is equal to 4. When the fractions get a little bit more complex, there's a couple of rules you can do, but I find it's easiest if you just take the smaller power away from the larger power. So when you've got a fraction like this, and you've got x to the 4 and y2 over x to the 1 and y to the 5, for the x's, remember, just deal with the pronumerals by themselves. So x's deal with x's, y's deal with y's. Smaller number here is the 1, so you take the 1 away from the 4. So 4 take 1. And that'll equal 3. And then over here, we've got y to the 2 and y to the 5. So 2 is the smaller one. So we'll take that away from the 5. So 5 take 2 is equal to 3. Now, if you did it the other way and you took 5 away from 2, you'd get a negative indice. And we don't want that. We don't want negatives. We just want positive indices. They're easy to deal with. Negatives are not. But we did before kind of defeats that. Next rule, index law 3, is pretty straightforward. So we've got a to the power of negative m equals 1 over a to the power of m. And a to the m is equal to 1 over a to the negative m. Anyone confused? I bet there's a lot of letters in here. But an expression with a negative index is the reciprocal of the expression with a positive index. So if I have this, remember that any whole number we express without a fraction is really written as over 1. Yeah? So x to the negative 4 and x to the negative 4 over 1, they're the same thing. We haven't changed anything. We just never write this 1 underneath because it doesn't make sense. But what you can actually do is if you've got a negative at the top, you can actually flip it onto the bottom of that. So put a 1 up top and put your negative down the bottom. But now that'll become a positive. Yeah? And same, if you've got a positive and for some reason you want to make it a negative, that works as well. So whatever side of the fraction it's on, if it's a negative, you just put it on the other side. But that. So I want you to pause the video, give these ones a go, just a couple of the rules that we've used, try those, and once you've given it a crack, resume and I'll put the answers in. And we're back. So I've already written the answers. In this middle column here in the blue, I've just written what index law it was. So we've got index law 1 up the top, we're multiplying together. So a number multiplied by itself, you add the indices together. Index law 2, so, number 1, we better actually answer it. Z to the power of 4 plus 9 is the same as saying Z to the 13. And the second example, we've got W6 divided by W2. We use index law 2. When they're being divided, we take the numerator away from the denominator. So that was W6 minus 2. 6 minus 2 is 4. Pretty straightforward. Now this next one kind of uses 2 rules. Some of you might have skipped a rule, and that's fine. That works as well. But if you used rule 2 and did the numerator take the denominator, you would have ended up with x to the power of 3 take 9. And that gives you x to the power of negative 6. Now, what did I say about negative indices? We don't want them. We want positive. So if you used rule 3, how a negative indice, you flip it, you use the reciprocal, put a 1 on top. So that x over 6, although we don't write that 1, that's how it's actually written. We don't normally write the 1 underneath, but it's always there, just to show that we're using whole numbers. And to finish that off using rule 3, simply flip them. Oh, why did I write a 3? X to the power of positive 6. Always express your indices as positives. Great. 3 rules out of 5 done. We've got 2 more. They get even easier. Index law 4. So indices outside of the brackets multiply all the indices inside the brackets. So x to the power of m, and we've got brackets around that, and then we've got to the power of n. So everything inside that bracket is to the power of n. We're simply multiplying the 2 powers together. Don't confuse this with index law 1. How when we're multiplying x to the power of something by x to the power of something, we add them. When there's a bracket, we multiply. So for the first example, we've got x to the power of 2 inside a bracket, and then we've got to the power of 4 outside. Pretty easy. X 2 times 4 is the same as saying x to the power of 8. And this next one deals with them separately. Don't multiply them all together, but just multiply this 3, just like we did with brackets. Multiply this 3 there, and then multiply it there. So we're going to end up with x to the power of 3 times 3, and y to the power of 2 times 3. And 3 times 3 is equal to 9, so x to the power of 9. And 2 times 3 is equal to 6, so y to the 6. And that's our answer. Index law 5. Last one, my favourite one. Anything at all to the power of 0 is equal to 1. And you've already kind of learned that, because when we're talking about cancelling out, this example down the bottom, we've got x over 4 on top divided by x on 4 down the bottom. If we were to rewrite that, it'd be x times x times x times x. That's going to be over x times x times x. Now, if you're new to my class, do not write x's like this. That is the multiplication symbol. This is an x. I should have mentioned that earlier. That's an x. Only write it like this, ever. Nothing else. Otherwise, you're wrong. Sorry. Back to it, though. If we've got x to the 4 up top, x to the 4 down the bottom, we're going to cancel out those x's. And remember, when we cancel, they don't just disappear. They become 1s every time we cancel. Because if we divide 4 by itself, 4 divided by 4 is equal to 1. 100 divided by 100 is equal to 1. So anything divided by itself is equal to 1. And if we cancel these out, we're actually left with x to the power of 0. Or if we did the other way, and we wrote it as, we used index law 2, and did the numerator take the denominator, that'd be x to the power of 4 minus 4, which is equal to x to the 0. Does not equal 0. You could have 100 to the power of 0 and it will equal 1. You could have 1,000,000 to the power of 0 and it will still equal 1. So anything to the power of 0 equals 1. Alright? That's index laws. Get cracking on the next chapters. I believe it's G and H. By next week, I expect F, G, and H to be done. Thanks. Good luck.